This lesson is on simplifying imaginary numbers. Remember, we get an imaginary number whenever we try to take the square root of a negative value. So here's just a little reminder on the bottom of all of the things that we know about imaginary numbers, that I is the same as the square root of -1, that if I square that, of course, I would get a -1, and that if I take the square root of a value, that no matter what, I'm going to move that negative to the outside as an I. When I'm simplifying these values, and this is a good reminder of just simplifying radicals in general, remember that I'm breaking it down into a perfect square factor. So if I'm taking the square root of 50, I'm going to rewrite that as the square root of 25 times the square root of 2. The square root of 25 is 5. The square root of 2 is ugly, so it stays on the inside. So my answer is 5 on the outside and radical 2 on the inside. For radical 64, the square root of 64 is 8. So I'm not going to break this one down because it's already a perfect square. So that one is just 8. The negative square root of 90, notice here I've got a negative on the outside. That does not mean that it's going to be imaginary because I'm taking the square root of positive 90. Again, I'm looking for values here that are perfect squares. So I see people who say, well, this is 45 times 2. Well, it certainly is, but 45 and 2, neither are perfect squares, but 9 is a perfect square, and 10 is whatever's left over, which leaves me with an answer of negative 3 radical 10. So the negative from the outside stayed on the outside the entire time. Now here on the right side, if you'll notice, we've got negatives on the inside of radicals, which is going to change things a little bit. Again, first I'm going to break it into 3 values instead. So this negative is going to be the square root of -1, which of course will turn into an I. 40, again, could be 8 times 5, etc., but I really want whole perfect square values, so I'm going to take radical 4 times radical 10. Radical 4 is 2. Radical 10 could break down into 2 and 5, but again, not perfect squares. So that's going to stay on the inside. So my answer is 2I radical 10. For my next question, I've got negative radical -32. So again, whenever I see that negative on the inside, I break it into 3 bars instead, and one of them is the -1. 32, there's a lot of things that multiply to 32. I'm looking for a perfect square. Some would say 4 times 8 would be good, and it would be good, except that 16 is the larger perfect square that also goes into it. So I'm going to call this 16 times 2. The square root of 16 is 4. The square root of 2 is ugly. So that leaves me with a 4 and an I on the outside and a 2 still on the inside. And last one, radical -16. Again, I would break this just into 2 parts, -1 and of course 16. -1 gives me I, 16 gives me 4, so my answer is 4I. Here are 3 for you to try, so press pause, do these questions, then press play to check your work. For the first, I've got the square root of -36. Again, I would just break that into 2 parts, -1 and 36, which would of course give me 6I. Over here, I've got the negative on the outside, which I'll ignore completely at first. Looking at 14, I'm breaking it into -1. 14 would break down into 2 and 7, though neither are perfect squares. So I'm going to leave that on the inside, which leaves me with my negative and my I, and the 14 is still on the inside. And the last one, the square root of -75, I would break that into -1, into 3, and into 25. The square root of 25 is 5. The square root of -1 is I. Radical 3 is ugly, so the 5 and the I are on the outside, and the 3 still on the inside. When you are simplifying imaginary numbers, you do need to be careful the order in which you do it. So I wanted to show you this example with multiplication. If I'm simplifying each, then I'm multiplying. I would simplify the square root of -4 to 2I, and I would simplify the square root of -25 to 5I, And if I multiplied those, that would give me 10I squared. Well, I know that I squared is -1, which would give me 10 times -1, or -10. When I do it the other way, however, if I multiply first, -4 times -25 gives me +100, and the square root of 100 is 10. This is an incorrect answer, and -10 is correct. So just be careful when you're dealing with those negatives on the inside of radicals, that you keep in mind that you might end up with some I values, imaginary values. Now let's look at the same type of example with division. If I were to simplify first the radical 90, that would give me I, and then of course I would reduce that to 3I and then radical 10. If I reduced negative, or the square root of -10, that would give me I radical 10. Reducing this, the i's would go away, the radical 10s would go away, and I would get 3. Now let's take a look if I divided first and then simplified, which means I'm going to put it all under one radical. I'm going to reduce what's on the inside. So I'm going to take -90 divided by -10, which is +9, and then take the square root, which is 3. So here notice I get the same answer either way, but in the other example I did not. So just be very careful. Here are 2 questions for you to try, so try them both and press play to see how you did. For the first, again, I'm going to ignore this negative on the outside until I'm done with everything else. I'm going to reduce the -64. That's going to give me 8I. And then, of course, the negative on the outside I'm going to keep there. The square root of -4 is 2I. Reducing 8 by 2 gives me 4. And of course the i's cancel, so my answer is -4. Doing the second question, again, this would be I radical 3 times I radical 3. Multiplying I by I would give me I squared. Multiplying radical 3 by radical 3 would give me radical 9, which is 3. This I squared turns into a -1. Which gives me my answer of -3. So on this one, you would have to be careful not to multiply those to find +9 and get a +3.